Alright, so we want to try to solve 2.1 number 7, which says you have xy prime plus the quantity 1 plus 1 over log x times y is 0. And we have an initial condition of y of e is 1. Please everyone note, y of e is 1.
Yeah.
So first things first, what kind of beast is this?
First order,
Linear, partial,
linear,
I'm getting
ordinary differential equation.
ODE first, right?
homogeneous,
And it's homogeneous,
Oh gosh, I forgot that much.
homogeneous.
and it was what order?
Oh, first
First order.
First order,
Linear.
and it was linear. Okay, so how do I solve first order linear homogeneous ODEs?
With the E trick thing?
Yeah, with the E trick thing.
I don't know.
So-
It has the word para in it. I know the word. I need to know this word.
Yeah.
Variation of parameters.
Yeah,
Not yet.
No, because it's a non.
good.
Yeah.
You need variation of parameters if it's non-homogeneous. The first step when you're solving a non-homogeneous equation is to solve the homogeneous version, so we should be able to do this.
You do algebra and stuff, and you subtract things, and then you say, hey, y's and x's, and then you do things with e and absolute value, you add a into it, and then you have an answer.
Okay, so
You should teach class.
not necessarily because this is the best way. The best way is to frankly remember the solution.
Yeah.
But because today's separable day, I'll do it the separable way. So multiply through by 1 over x. So that gets you y prime plus 1 over x plus 1 over x log x times y is 0.
Yeah.
Subtract the stuff in the parentheses. Yep. Y prime is minus 1 over x minus x log x times y, right?
Survival step by life.
Yeah, so I'm gonna also multiply by 1 over y.
Yeah.
Well, I mean, I know it's y prime equals e to the negative integral of some.
Oh shit, you already knew the answer. Okay, so if I was gonna finish separating,
I didn't know it was to do with that x thing in all honesty. When it goes x, y prime. I was like, well,
oh yeah, just divide through by it.
let's see where.
So this is 1 over y dy dx is minus 1 over x minus 1 over x log x. So multiply the dx to the other side. And slap squiggles on there. So you got,
You're not going to do the u sub for us, Joe?
what? No. So you got natural log of the absolute value of y is the integral, oh wait, I can do that.
Wait, what?
What's the integral of 1 over x?
The natural log of x.
Okay, cool,
Well, it'd be the negative natural log, wouldn't it?
good. And then the other one, maybe I'll just leave that one here for a second. How do you do the integral of 1 over x log x?
Let u equal x.
Let u be log x, then du is 1 over x dx,
Hey, it's in there. Jesus.
which you have.
That's a balance.
So this is natural log of the absolute value of y minus, equals minus the natural log of the absolute value of x minus the integral of 1 over u du. So there's a lot of natural logs everywhere.
So
Right?
We can do that integral, which is
Natural log.
natural
Which is
log of
natural log.
Natural log of absolute value of u, sub back in natural log u.
Yeah. But, yeah. it
So
cancels.
log absolute value of log of x.
There's too many vertical lines.
It's like,
Plus C.
wait.
Oh wait, also the absolute value of x though.
Also add a c.
No.
No.
Do we have to stack
Oh,
absolute
because
values?
it's the
Yeah.
It's already the absolute value.
too many. Okay.
Okay, so you have here
I can't even tell what that is.
E all of this crap, right?
Exponential.
So you have the absolute value of y is
A.
e to the minus natural log of absolute value of x times e to the minus log of x times e to some frickin' constant c.
Yeah.
And then you're like, alright, so I'm gonna take this and absorb it into plus or minus e to the c.
Yeah.
And then you need to do some trickery with exponent rules. Like, these can get drugged into there using a log rule, and then you can drop some stuff. So you should get y is 1 over the absolute value of x times 1 over the log of x times some number a.
We put those together.
These two guys?
Yeah.
Sure.
There's still an absolute value over the natural log as well.
Oh, and there's still an absolute value here. And then you're like, okay, cool. Now what? You had an initial condition, right?
Walk away.
Yeah,
Walk away.
it's not one.
Why is it easy to one?
So why are these 1? So 1 is what you get when you plug e into this side, right? So that's a over the absolute value of e times the absolute value of the log of e.
So it's A over E.
So that's 1 is a over e. So a is
E.
e. Check. Cool.
Well,
Yeah.
Can you multiply those and combine the absolute values? Or is that not something that's possible?
Oh, you mean can you do that?
Yeah.
I'm not sure if that's a rule. but-
Sure.
Okay.
I mean, it's kind of
Because you can
redundant,
pull
yeah.
out negatives in it. Okay.
Yeah, so the kind of the rule that you're applying is this a times b in absolute value is equal to the absolute value of a times the absolute value of b.
It's like we're just factoring.
That is in fact true. We usually use that this way, but the other way is also true.
Okay.
Sure.
It's like factoring an absolute value.
No, it's like the absolute value function and multiplication commute.
You just have a random absolute value hanging out somewhere. Nothing in it.
Yeah.
You divide both sides by absolute value.
So-
Maybe.
So really, that's a question about function composition. That's really a question about does like g composed with f actually equal f composed with g? Usually the answer is, oh hell no.
Right.
Right. It just so happens that this pair of functions, multiplication and absolute value, commute.
You can just pull out a negative one anywhere.
Yeah.